I think it's probably a great time to get started. Um, Want to welcome you guys. Thanks for stopping in to another Opus IVS webinar. Uh, you guys probably know me. If not, I am Aaron Jones. I am the Tesla Master Tech for Opus IVS. So if you put in any Tesla support tickets, it usually comes right to me. Also have my hand in helping some collision work and other EV stuff. So kind of excited. We're really stepping into a little bit more of high voltage diagnosis. So it's going to be a nice little glance over of what we can expect. Now, if you guys are digging the Opus webinars, make sure you go to opusivs.com, go under the support tab, and make sure you keep up with all of the training that we have coming up. I know that I was talking with Brandon earlier, for you guys who know him, and our webinar curriculum this year is looking pretty strong. So we're gonna have a great year for teaching and really getting out there and talking to you guys. So that being said, let's talk about isolations. Um, Realistically, where we all are in the shop, more or less. Let's go ahead and hit the 80-20%, right? Um, Isolation testing is going to be one of the only high voltage diagnostic aids that we use. The reason I say that is that a lot of other high voltage testing kind of steers to more of a niche market for those who are simply rebuilding motors and batteries and other components, where isolation is kind of more of a, I don't think misfire is the right word, but it's almost as popular with the electric vehicles, and it's something that every manufacturer has. Every manufacturer has to deal with. Um, but today we are going to focus mainly on Tesla. We're going to start off the hour going through kind of what isolation is. We're going to go through diagnosing, and then we're going to go through some of the most common faults that we see in the Tesla lineup. Now, one thing that I do want to mention is that isolation testing is high voltage testing. So that means proper PPE needs to be worn at all times. Just to give you guys a heads up and maybe a look into the future, we're going to talk about sending 1,000 volts into a circuit. We are sending 1,000 volts. So it's good for us to have our proper protection on. It's necessary for us too. So with that, let's hop in to what isolation failures are and kind of how we're going to tackle them. So first, the main question on the board, wherever I am, here I am. Let's talk about what is isolation. So when it comes to electric vehicles, you're going to have two different buses of voltage. You're going to have high voltage and low voltage, or high voltage and mid voltage. We're seeing some of those 48-volt cars coming out. To keep it simple, let's think about 12 volts and, I don't know, 400 volts DC. Isolation is going to be a protection system that separates these two systems completely. Isolation is going to be the resistance value of the high voltage bus to the low voltage or vehicle chassis. So if you think about it, we don't want high voltage grounding to the chassis. Driving around a big taser may seem cool, but in realistic, it probably wouldn't be very fun. So if you think about it, it's electrical barrier, basically an electrical resistance barrier that is keeping high voltage from leaking into the chassis into other low voltage components. You may see other companies, other manufacturers refer to it as like a high voltage leak down. Um, the Federal Motor Vehicle Safety Standard refers to it as electrolyte loss or something like that. Kind of silly, but we're gonna know it as isolation. Um, this ensures that a single fault in like the high voltage system, a short, an overcurrent, and over voltage, isn't going to expose anybody to a high voltage electrical shock. So, how does it work? Think of the high voltage battery and the high voltage system as like your cell phone, right? There's no ground, right? It grounds to itself. So, in the electric vehicle standpoint, most of the times the high voltage battery is going to be the grounding location. Sometimes we see drive inverters, drive motors, we see pre-charge capacitors and other older EVs, but most of the time, the battery management system, which is going to be located near or in the high voltage battery, is going to run the isolation testing, and the battery is going to be the start and the end of that circuit. Now, the high voltage system is still going to use low voltage, right? It needs low voltage communication for temp sensors, pressure sensors, flow, current voltage sense, all kinds of things. But even though we use a low voltage circuit for sampling and for sensors, we are still going to run the high voltage circuit parallel. Kind of think of like the low voltage sensors that will read the current on the bus bars. You know, they are there and they're doing a job, but they're not part of the high voltage system. Isolation is going to be something that we see protecting not only the high voltage components, but we're going to see the cabling, the connectors, inverters, anything that has to deal with that voltage is going to have some kind of isolation value to it. That makes sense to everybody. Let me get my questions just in case anybody shares. Boom, no one has yet. Perfect, perfect. All right. So, what needs isolation, right? Here's the Federal Motor Vehicle Safety Standards for electric powered vehicles, electrolyte spillage, and electrical shock protection. I'm not gonna lie, first time I saw electrolyte spillage, I definitely thought of a Gatorade getting kicked over. But that's not it, right? So by this standard, they teamed up with, the Highway Transportation Association, and they found that if you're going to have an AC system that is going to be over 30 volts, which is what we consider AC as high voltage, it's going to need 500 ohms per volt. So per every volt that goes through this system, it needs 500 ohms of resistance between the vehicle chassis. Now with DC, we see it drop down a little bit, right? We see 100 ohms per volt, and that high voltage rating is going to be at 60 volts for DC. Now, I know we're at the end of the workday for some of us. I wish I knew my geographic times a lot better. I can't tell you what time it is in Brazil, but we're going to do some math. Not hard math, and I've already solved it all for us, okay? So you don't really have to do it, but just, cheers along with me. So let's take a look at these three vehicles. We have a 2018 Model S. We have a 2022 Ford Mustang Mach-E, which is actually what I drive. And then we have a 2023 Tesla Cybertruck. So let's look at the S first. The Model S has got a 350 volt lithium ion DC battery. Now, if we take what we learned from the FVMSS, we know that we need 100 ohms per volt, right? So we're going to be looking at a standard of 35,000 ohms, 35 kilo ohms, right? The crazy thing is, and what we see with a lot of manufacturers is they don't care what they need, right? They're going to set such a high standard that they never have to worry about imposing that damage onto somebody else. So, Tesla spec for the 2018 Model S with contactors closed is going to be 1500 kilo ohms. Excuse me, contactors open. So you can see where the manufacturer has way overstacked what any other standard that has been set by a federal board, and they are out there to just protect consumers in whatever way possible. And it's not just Tesla. I mean, take a look at Ford. Ford has a 400-volt DC battery, right? 40 kiloohms. That's what we expect. 400 kiloohms is Ford's specification. Now, where we see things differ is we take a look at the Cybertruck. So we're kind of walking away from that 350, 400-volt system that a lot of these EVs use. Um, and we're looking at a 700-volt system. So a lot of the numbers and a lot of how we diagnose this truck is going to get amplified. So we see the Tesla specification for contactors open being greater than 6,000 kiloohms. FVMSS said they only need 70. Now, OEMs, they're going to set that software flag much higher. Like I said, it comes down to what does a vehicle do in a crash? What does a vehicle do with overcurrent, etc., right? The higher, the better. So, what causes these issues? Well, I'm very glad you've asked because I've prepared. First, the one that we are going to talk about is going to be the electrical stresses that we see from the system, right? Overcurrent, overvoltage. Two of those things, they're just so bad for a high voltage system. Overvoltage or overcurrent issues usually will weld the contactors shut, the high voltage contactors. We saw that a lot with the Mustang Mach-E. We saw the recall come out. We saw it with the Bolt. Now, that's not a super common occurrence inside of Tesla's world. All right, kind of what we're going to see is a lot more of mishandling of the components. Let's think loose bolts, right? So if you take a peek at that picture, I know it might be just a little, I do have a magnifying glass. You can see right there, that bolt was left loose, right? So this customer came in, they were getting vehicle may not restart, acceleration reduced, performance reduced, and then it would be gone and come back and it'd be gone. It would come back and be gone. And technician took a while trying to figure out where it was coming from because full transparency, charge port, which this is what that is going to be very last almost on your testing diagram. Charge port doesn't fail that often. But once he spent the time testing everything else, he had to go to the charge port and he saw that the charge port had just recently been replaced and we had a loose bolt. We can also see this kind of the same thing, and we'll talk more about it in like mechanical stresses. But when we see cables that aren't routed correctly, and we see wear and just little things like that, electrical stresses. Now, oh, I forgot I have a magnifying glass. Next up, we have chemical stresses, right? This is going to be vapors or liquid that are actually inside of the components. With Tesla, this could be like a large rear drive unit that has the coolant intrusion. It could be the battery coolant heater that coolant blows past the seal. But a lot of the times when we talk about chemical stresses, we're talking about it inside of the battery itself. Whether that is a coolant bladder that has exploded or a seal that is cracked and allowed outside influence, such as flood water, rainwater, or something into the battery pack. Now, this car that I have this picture from, this customer, I believe it was in one of my Tennessee stores. Customer came in for a warranty battery, no biggie, got it replaced. 6 months down the road, battery goes bad again. Gets it towed into Tesla, and he says, hey, just had this battery replaced. Can you guys take a peek at it? Tesla had no problem with it. Had the car for, I believe he said, 2.5 weeks. Came back to him and said, hey, sorry, this battery's not under warranty because it is filled with water. And he said, how is that possible? And they said, well, you must have driven through a flood or something, right? Well, the problem is that his part of Tennessee hadn't seen rain like that in years, and he didn't drive through a flood. So back and forth with the service manager, and he talks with the technician, and he asks the tech, he's like, "How did water get into my battery?" If you guys look real closely, you don't have to look closely. See all these cracks? This is where the seal tore apart after the first battery was dropped. That allowed the water to get inside. Once they figured that out, battery was placed under warranty. But it's not really the will it or will not be covered in warranty that's the biggest issue when we talk about chemical stresses, especially inside the battery pack. The biggest issue is the safety, the integrity of that battery pack. Um, we'll talk a little bit more about the types of isolation, but an internal isolation is going to be inside of the battery. So if we see whether it's coolant, water, seawater, salt water, anything like that that is possibly entered into the battery pack, a little bit higher of a caution needs to be taken. Um, Other components in the high voltage system is a little bit safer because they can be de-energized by opening the contactors. When we look at an isolation in the battery pack, there's not really that protection because we're pre-contactors. So we are in the war zone of cells that could be possibly over temping, right? They could be getting super hot, they could be getting cool again. We could have a voltage. So their deviation is 20 millivolts, right? Between two different bricks. So what you want to do is once you start seeing a possible water issue vehicle is you want to measure these vitals, right? You want to take care of it because when we start short circuiting or flooding cells is when we start seeing heat, right? And when we see heat, well, you know what's next, right? Now, thermal events from isolations are very rare. Heck, I don't even know if this car caught on fire because of it. But it is something that we need to be careful of, right? If you see any of these issues, whether that is the temperature fluctuation, you see the voltage fluctuation, you need to get the battery pack or the vehicle back outside. 30 meter bubble is what Tesla calls for. And you're actually just going to sit there and you're going to kind of monitor the system, right? You want the system to stabilize before really having to go any further. But we'll talk a little bit more about diagnosing and repairing this later on in the hour. Now, next up, mechanical stresses. This is kind of what I was talking about, routing those cables correctly. There is insulation, isolation in these cables, right? If you're in a car accident and you snap this cable in half, if I don't have any isolation protection in the cable, well, you're getting shocked, right? This is also when we can see like direct damage to a high voltage component, such as the drive unit, the battery. This could also be like internal shorts to resistors or IGBTs or circuit boards. That just leads to the isolation issue. Sometimes they insert a high voltage cable in incorrectly, right? And then over time of bouncing and taking that current over and over again, we start to see the leads wear out, get hot, burn themselves out, right? So, one example, let's take a look at this Model 3 PTC heater. We have a little bit of a damage, right, to the PTC heater because of transit. Well, that little damage over time gets worse, right? We make thermal stress fractures. We start getting dirt and oil and grime inside of it. And then eventually, one of the resistors that heats this grid is going to fail. And that is the beginning of our isolation. So, isolation, it happens, it sucks. What does it mean for the consumer? Well, I can talk about Tesla, right? So, if your car is charging, if it's in support, or if it's in standby, just sitting in a parking lot, your contactors are going to open, right? If it detects that there is a drop in the isolation resistance, it's going to go, hey, we can't drive like this, right? Slap them open. And contactors aren't going to close again until the battery management system can go, okay, externally and internally, our resistance is fine. Go ahead and close them. Now, as techs, we often get these vehicles brought into us completely dead, right? So we think of, oh, what all could this be? And the reason that the vehicle is completely dead is because with contactors open, not being able to close, we basically have stolen the alternator from this car, right? It's no longer able to support the 12-volt system, the low voltage system. So eventually, that low voltage battery is going to die out. Um, and you're going to have to jumpstart to even get it into the shop. Now, if you are driving, first thing that you're going to get is you're going to get a warning. Okay, vehicle may not restart. Acceleration and top speed reduced. Now, if we look at that middle section, you're going to go, oh, it's a heating or air conditioning circuit. Nope, that's just there because we're trying to take some of the load off of the vehicle, right? So if we're driving, we get that warning. Once the vehicle stops, once you put it in park and you get out of the car, when you've opened contactors, they're open. They're open until they get a reported good isolation value. So, if you see or your customer sees one of these alerts, don't stop driving it until you can get it to where it can sit for a while or sit till it can be repaired, right? Now, it is totally possible that you park this car and you leave and you come back and the BMS is tested for a good isolation value and you can drive away. It is something that we see with rear driving it issues, mechanical stress issues, and things like that, where it's just intermittent. You have to hit just the certain spot on the stator for the rear drive unit to fail. Now, here's your 12-volt battery, power reduced, vehicle may not restart, and then this is how it gets brought to us. Cool. Questions? Let's see one. All right, so we started this class at 2100 hours. So that's 9 p.m., right? Yeah. My clock only has 12 hours. So, just kidding. The thing about webinars is you can never really hear anybody laugh at your jokes. So, you kind of just have to laugh with yourself. All right. Now, we know what isolation is. We know what happens when you get isolation. What do I need to diagnose it? What's next, Aaron? Okay, yeah, I hear it. It happens. What can I do about it? First thing you need, it's going to be PPE. Okay? You're going to need to be able to protect yourself. Like I said, we're going to be dealing with high voltage. I really recommend that if this is kind of your guys' first dive into high voltage diagnostics and testing and stuff, it's really important that you sit and you take some kind of safety course. Whether it's hybrid based, whether it's EV based, just make sure that it's taken care of. Okay? Make sure you're taken care of. Now, the next thing that you're going to need is a mega ohm insulation tester. Okay? Now, this is kind of where I can add a personal tidbit that's not what Tesla says. Tesla recommends a Fluke 1503. Or excuse me, not a 1503. I believe it's a 1507. It's not the one that I have pictured, so please pardon me. They want a Fluke, and I love Fluke. It's a fantastic brand, right? The only problem is you're looking at around $700-800 bill to have this insulation tester. I have had a Klein Tools ET600 for the last 5 years. It's got the same specifications as Fluke. 1587. That's correct. Thanks, Craig. The Klein Tools is great. It allows me to test up to 1,000 volts. It's Cat 3, so it's good for 1,000 volts. I got it overnighted with a few other attachments from Amazon for $167. That's just me. Of course, if you want to go with the Fluke, I grew up with electricians, so Klein Tools kind of made sense to me. Now, the reason that Cat 3 is so important, okay, we're not going to always be dabbling with 600 volts ish, right? We're going to be dealing with now 700 volts with the Cybertruck, 800 volts with the Porsche Taycan, 800 volts with the Hummer EV, right? So we need something that is going to be able to stand the test of time, um, where we will be able to increase our voltage and increase our diagnostics and not outpace our meter. Harley, yes, the Klein ET 600, 600. No problem. All right, next thing. Tesla had to seek some software in there, right? Next thing that's going to be kind of important is Tesla Toolbox. Toolbox is Tesla's diagnostic software. And the reason that it is important to have is that Tesla is going to walk you through isolation testing of each component via articles. It is also going to give you the ability to clear isolation counters, whether it's inside of the BMS or the other high voltage system. Now, what would I be if I made you rely on Toolbox, right? Now, if you have a Drive Pro, 1 or 2, and the Tesla bundle, we are happy to help. Tesla's included with your 360 coverage if you have it. And if you don't have the cable bundle, they're only $99. Reach out to your sales. They'll be happy to send you one. We have access to Toolbox. We have access to all of the information. And not only that, you got me. I've got some personal hands-on training. I'm happy to walk your techs through it. The only thing we do ask is for that hybrid or HV safety cert, and you're golden. We'll be happy to help you out. So, once you give me a ring and we're looking at this car, it's time to kind of walk you through how we're going to start our diagnosis, right? Let's talk Tesla. With Tesla, we got 2 types of isolation, right? We have internal isolation, which means the contactors are open. So if we think contactors are open, that means all of our energy is stored inside of the battery at this time, right? So we have not started our discharge mode. The second one is going to be external isolation. This means the contactors have closed, and now we are discharging high voltage to other components inside of the vehicle. So how do I know which one, right? Well, you could read the isolation value off of Tesla's garage page, or you could just look at alerts, okay? You're usually going to start out with this BMS A035. It's just going to give you I've got an isolation. And if you go to this Toolbox article, it's going to say, hey, the vehicle recognized a low isolations when contactors closed. It's not going to quite tell you whether it was external or internal. But if you keep digging and the issue has happened more than once, hey, BMS A151, it could be A, F, W. All we care about is the description at the end, right? External isolation. The battery management system detects that high voltage isolation is too low while PAC contactors are closed, right? Inability to charge, drive, or support the low voltage system. Or internal isolation. Battery management system detected that there's a low high voltage isolation when PAC contactors are open. So like I said, internal, super easy. It's inside the battery. External, it's everywhere else. So we're going to start with the most common isolations that you're going to be testing. And that's going to be external, right? This external isolation, it's going to be AC compressors, PTC heaters, DC-DC converters and power conversion systems, drive units, etc. It's going to be anything past the contactors, right? An external isolation fault is set when those contactors close and we have an isolation issue outside of the battery. All right. So the good thing about Tesla is that they're going to give you every single component that you have to test. And they're going to walk you through, hey, disconnect this, test from this pole to this pole. We're going to test with the pyro fuse installed or without the pyro fuse installed. They sit there and they talk you through each one of the isolation testings per component. Not only the components that are important, they're going to kind of try and walk you through harness testing as well. Harness testing is pretty important. I know that bottom one says front drive unit, but let's pretend like it says rear drive unit, right? With the large rear drive units, we've had a coolant intrusion issue. Had it since the jump, right? It was the only drive unit that Tesla put the coolant directly into it instead of a chiller. It is not uncommon for us to find coolant at the positive and negative lugs of the high voltage power for the drive unit. So being able to test whether or not the corrosion of the coolant has caused an issue in the harness from the rear drive unit to, let's say, the high voltage junction block, or if the isolation is just stored inside of the drive unit. It's kind of important for us to know how to test both of them. John S., can you do any of this with service mode, or do you have to use Toolbox? So, you have to use Toolbox. The only reason I say that is because with service mode, we can check the Toolbox articles based on alerts. But if you look back, these aren't alert-based articles. These are, I guess the best way to explain it is title-based, situational-based. So service mode, they would let you, hey, I'm going to describe this alert to you, but they're not going to walk you through each individual step. Boom, 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 boom. I'm a question answering machine. All right. Come on. So let's talk about diagnosing it. It's very easy to do. I promise you. I can do it. It doesn't take a rocket scientist. Now, you got a chassis, right? Here, just in case you didn't know, chassis. All right, let's slide that over to the side. You got your meter, okay? Now, when we're testing, right, we need a very good chassis ground. The chassis ground is extremely important because we are testing the resistance from a high voltage component to a chassis ground. I have seen measurements be messed up by people putting a dangly alligator clip on door latches, or excuse me, door strikers, random strut bolts, random painted parts and subframes. Find a good chassis ground. It's going to be extremely important. It's really going to kind of push you to know that you've got good results. So, with your insulation meter, it's a little difficult to see, but I'll do a little zoom in, right? You can see over here with the 4,000 mega ohms, we've got 125 volts, 250 volts, 500 volts, and 1,000. We are going to be testing with 250, 500, and 1,000. So 250 volts is going to be something that we test for or use to test PTC heaters, AC compressors, and other certain harnesses, right? 500 volts is going to be for mostly everything else, except when it comes to the Cybertruck. Now, the Cybertruck, we're going to test almost every component at 1,000 volts, right? And older S and X charge ports are also 1,000 volts, I believe. So there's going to be a different value that we actually have to put into the vehicle. And it's very crazy. The thought of this when I first joined Tesla kind of blew my mind. That meter takes 4 AA batteries, right? And you're going to tell me that I can put 1,000 volts into it. Now, I did have this question, and I don't think that it's a proper class until someone asked this question. What if I stab myself with it? First off, you didn't take that safety course. Second off, don't do that, right? You are producing this voltage. That is why PPE needs to be worn through the whole testing procedure, right? It wouldn't be fun, by the way. It's a cheap taser, though. Shock stick. All right. Now, we've got our component. In this, it's going to be, this is going to be a Model X DC to DC converter, okay? So, got our PPE adorned. We found our article. We've reviewed it. We're coming back. We've got we got our meter set up. We're producing voltage, so we know that we got to be careful. We're going to find our chassis ground, right? First thing that we're going to do. Next, with our article, it's going to kind of depend on how we start our testing. I will say that for 90% of your components, it's going to be B plus to chassis ground and B negative to chassis ground. Now, there are going to be some components where they want you to test different legs of the voltage system. DC-DC converters, high voltage junction blocks. There's just different parts where high voltage enters and exits those components. For this DC-DC converter, we are just going to be testing B plus and B negative. Harley asks, good chassis ground equal to 12-volt battery ground? Or from lighter auxiliary plug? I would say 12-volt battery ground if you can get it. I will say that a lot of the times you'll have a hard time finding Cat 3 leads that are going to be that long. I find that Cat 3 leads are usually pretty short. But if you got something, make it work. All right. Answer live. Now, we're going to go to our B plus first, right? We go here, and then your tool, whichever one you've decided to use, will either have a start button or a test button. So with ours, we have a test button. Now, kind of fun secret is if you hit test and then you hit continuous lock, test stays until you find your next component. So if you're careful with it, you don't have to hit test every time. But we did our test, right? So it's a 2018 Model X DC to DC converter. Tesla wants it to be tested at 500 volts, and we're expecting a return of greater than 10 mega ohms. All right? That is a lot of resistance. So, chassis ground, we're going to B plus. We get 32.4 mega ohms. Boom. That side's good. We send it, right? We ship it. It passed. No, you gotta test the other side of the circuit, right? So here we go. Chassis ground, and now we're going to be negative, okay? Press our test button, 500 volts. We're expecting 10 mega ohms. Oh no, we actually got 7.4 kilo ohms. Not good. DC-DC's bad. Now, what's wrong with the DC-DC? Some of us technicians, we get the luxury of finding that out. For those technicians who don't have the luxury and have 3 other waiters waiting for you, there's probably going to be an issue with the printed circuit board on the inside. Whether we have burnt through, like I said earlier, an IGBT, whether we've burnt through a resistor or something along those lines, it's going to probably be something on that circuit board that you're not going to fix. Just being honest. So, get yourself a new DC-DC, get it replaced, program the car, ship it. So kind of just to go back over what we talked about, we're going to confirm the vehicle is off, right? We definitely don't want to be testing any of these components at high voltage without giving it high voltage. I always recommend locating your component and researching your article first. The reason for that is that I've seen a lot of technicians that I have taught isolation testing to. You have your positive and your negative lead, and then you're testing something underneath the car, but your meter still needs a hand to be held, and you still need to press the test button, and you don't know what you're doing, right? You don't know how you're going to do it all. So just take a peek, look around. Put on your PPE, find your chassis ground, set your meter, test your component or harness, exactly as the article states. One thing that we didn't discuss is you got to let that voltage leak off. Most of the Tesla, I'm going to say most because all is always a bad word to say when you're teaching. Most of your Tesla components are going to drop that voltage immediately. So as soon as you let go a test, the voltage from your meter is zero. Uh, there are components that will have capacitors in it, Tesla or other. And if you do introduce that energy, you just want to wait for that time to let the voltage kind of just leak off, let your meter get comfortable. 5 to 10 seconds. If you see that it's lasting longer than that, just wait. That's all you can do. Just wait. Now, external. I believe external isolation testing is very easy, right? This is where it gets a little bit more difficult, especially on an aftermarket level, is when we start talking about internal isolation. I think that we covered it pretty well earlier, where we talked about the danger of internal isolation and the high voltage system. Internal isolation is pretty rare. I will say that we had a case either last week or the week before in Norway. Customer reached out. Hey, I have isolation alerts. Digging into it some more, we found, hey, it had an internal isolation issue. That's not good, right? Started giving them the scoop. Hey, what happened? You might want to get that car out of there. We're watching temps. Everything seemed pretty stable. Come to find out, the car had been up to the bottom of its doors in snow and ice and finally thawed out. So we had water in the pack. We got that car out of there, and now we're going to kind of talk about what your next steps are going to be. All right. Always strapped with PPE. This is me. When I'm working with internal isolation, I've got my grounding shoes, I've got my gloves, I've got everything, right? Because this is a dangerous situation. Could be. The first thing that I like to do, right, is in Toolbox, there is the ability to get the owner's authorization. And what that allows you to do is review Tesla's garage. If you have questions about the owner's authorization or anything like that, check out one of my older webinars with Opus. It kind of walks you through all of this. And what Garage is a one-page document on live-ish information of the vehicle. From that page, we're going to be able to see exactly what the BMS is reporting. It's going to do a reporting of min and max voltage and min and max temp. We can also pull logs on the vehicle, and we can line up graphs to kind of see where and how stable or unstable the vehicle has been. Now, if there are any key indications, right, this car is fluctuating temp or fluctuating voltages, get it back outside. Eventually, hopefully, it will stabilize. Everything dries, everything leaks. At some point in time, more than likely, this battery is going to be okay. But if you see any of these, right, we've got over temp warnings, over current, thermal event, islanded brick, battery coolant flood, thermal shutdown, DC link over voltage, right? These are not good alerts. These are something is happening, and I want to get it outside of my shop, right? Harley, thank you. Do you recommend just cleaning the metal service? Bolts a bare clean service. Yes and no. There will be certain applications where cleaning the surface will be okay. But that's going to be one of those things that you kind of have to take experience by experience. Mr. Chavez, do we access Sandbox with paid access to Toolbox 3? Yeah, so you would use Sandbox in this situation. Perfect. All right. Like I said, isolate the pack, 30-meter bubble. Now, let's say usually what I like to do is I recommend, hey, reach out to your local Tesla service center. You can either reach out to your Tesla service center or your Tesla certified body shop and go, I've got a vehicle here with an internal isolation. I've got some fluctuation in voltage in the bricks, but my temperatures are stable. What should I do? What's next for me? Uh, Here's what we're going to do, right? And this will probably be the advice that they give to you. It, we're going to want to do our best to check for liquid, for possible liquid in the battery pack, right? First thing we want to do is inspect. We want to do our best to look underneath the car without bringing it into the shop and see if there's any physical damage to underneath the battery pack. Number one, if you have it, get on the phone with the customer, get on the phone with probably the Tesla certified body shop. This is going to be an insurance claim. That's what your next step is going to be. Maybe it hasn't been outside influence. Maybe we blew a coolant bladder. So we're going to take the frunk out of the vehicle, the little black trim, and we're going to check our coolant reservoir. If we see that it's empty or really low, we're going to assume that the internal isolation is being caused by coolant in the high voltage system. Now, if things have stabilized, or in a safety fluctuation, we're going to go ahead and bring the vehicle into the shop, and we're going to drop the battery pack. After the battery pack is dropped, go ahead and get it back outside. Now, Tesla does have, I don't have a picture of it. Tesla does have a connector, and it plugs directly into the low voltage port on the high voltage battery. And we use this alongside of Tesla's battery communication tool to monitor the battery once it's outside of the vehicle. It just communicates to the battery management system using its CAN network, and it will allow us to monitor and check fluctuations in temp and in voltage. Battery out of the car, we're still stable. Here's where it gets kind of dicey, a little weird. It gets a little hard for us as aftermarket shops. First, we're going to start trying to dry it, right? We're going to try and get all of the moisture out of the battery. You remove the high voltage fuse. You're going to remove all of the umbrella valves, and then you're going to remove the flood ports. And these are one-way ports for liquid and for air pressure to bleed out of the battery. We take them all out, and then we need to tilt the battery. We're going to tilt the battery up a little bit for about 10 to 15 minutes. And we're going to let all of the liquid drain out that we can. This whole time, we're going to be maintaining that voltage check and that temp check to make sure that we are safe and steady. After that, we are going to gain access. Now, if you have found coolant or water in this battery, yeah, that's it. Get a battery for it, right? Battery is completely dry. There's no signs of any kind of internal leakage. We're going to drop the battery pack, and we're going to gain access to the contactors. Because from here, we are going to test contactors back until we can find the source of the isolation. Now, read all of your articles. Your articles are going to be your best friend when it comes to internal isolation testing. It's going to show you, hey, you got all your voltage sense leads attached, got your voltage sense leads disconnected. You've got your pyro fuses in, you got your pyro fuses out, XYZ, and it's going to walk you through until you inevitably say you need a battery pack. 9 times out of 10, internal isolations are replacement battery packs. We very rarely see contactors being the cause of the isolation. Now, for all the shop owners and those who are in the chat right now, the big question that I know you're probably asking, how do I charge my customers for testing? All right? How do you test? How do you charge? How does Tesla charge? This is how Tesla charges them, right? 0.05. It's not what they really charge them, but that's what their time that they have posted is, right? It's supposed to be one of those that we stack a quote on top of with uh, de-energizing the vehicle and gaining access and dropping the air. Our customers who have access to Tesla service are going to want to pay that 0.05, right? Right? We don't want them to pay that 0.05. What we're going to search for is reasoning behind our pricing, and I got it just very easy for you. All right. That 0.05 is the physical probe into connector. That is all that they're charging. This is how I recommend my charging. Very easy. 1 hour. This is just for setup and preparation, right? This gives your technician time to safely check his PPE, check their meter, proof their meter, make sure everything is still good. It's going to allow them proper time to de-energize the vehicle, to test components to make sure that they are no longer energized. It's going to give them time to lift the vehicle and just physically be prepared for the testing. Now, if we are talking about just basic testing, I mean AC compressor, PTC heater, rear drive units, front drive unit, those things that don't really require a lot, we're going to charge another hour. The reason for this is one, we still have to be very careful, okay? But two, there are things that you're going to have to remove to get to these components. Let's talk first generation DC-DC converter, right? Out of a Model S, up to 2012 to 2016. Passenger front fender liner has to come out. Aero shields have to be dropped if you're going to be testing the drive unit. If you're going to try and test like a high voltage junction block or a master charger, rear seat is coming. So there's things that you need to add on to this time, right? So that hour doesn't seem like much, and feel free to charge more if it's going to take more time for your technician. Now, if that hour gets away from you and you start looking like you're going to be more in-depth testing, right? This is unplugging, removing harnesses. This is getting to the inverter versus the actual rotor stator of a drive unit. Whatever it may be, another hour isn't that hard to tack on. Now, with internal isolations, that is going to be something that's left up to you. That's going to be how comfortable you or your tech feels, how comfortable you are with your tooling, with your tables. Let's say you have a table, but it takes an hour and a half to get a battery flattened on it, you know? Whereas my pneumatic table can flatten it in 5 minutes. It's going to be really up to you and however you need to charge a customer to feel comfortable. Peter, I knew that question was coming. What is your hourly? Tesla's hourly hour rate for North Carolina right now, I believe I was told last week is up to $2.89 an hour. It's either $2.89 or $2.99. Now, that's going to depend on where you are on the coast. And me being in North Carolina, East Coast, I feel like it's kind of like the average kind of pricing. But when it comes to this type of stuff, I don't think that Tesla has finally realized how to properly charge customers. What Tesla's doing is they're charging them an hour of diag, and that's basically where it stays. So you could be 4.5 hours in this car, and you're getting the Tesla hour. The other thing to remember, Peter, is that Tesla pays their technicians via the hour, where you are paying the technicians or you are being paid per the job that you can complete. Tesla doesn't matter. They don't have warranty times, they don't have customer pay times, they have times. And their techs are going to get paid no matter what. So we can't shortchange the technician to try and save with the customer and possibly risk a safety issue. At least that's my opinion. Cool. So with the last few minutes, I want to kind of go through some of the common failures that we have seen in these vehicles, starting with number One, oh, got really kind of cool with my PowerPoint editing, you guys know. So, large rear drive units. Big old flop of failure. Just kidding. They're great motors. They did a really good job. The only problem is they like to leak coolant. They like to leak coolant a lot. Now, what happens is this is where Tesla directly shoots coolant into the drive unit. Now, other times with Tesla, they will mount a chiller, like right here, for their cooling needs. But no, with this one, drove it right into. Okay? So as you can see, popping off this front cover for the rotor stator, absolutely drenched. Here's your coolant galleries. Zoom in, zoom in, zoom in. Right here. And what's happening is some of these seals are only rated for a certain RPM. Okay? So once customers are starting to push these seals over 80, 90 miles an hour, we're seeing coolant kind of bypassing and going into the rotor and stator or going into the drive inverter itself. Easiest way to check that this is your issue, real quick, is find this speed sensor, right? This guy, that's right. Why can't I magnify and draw at the same time? That's 2025 PowerPoint. Right there, right? It's on the driver side of the rear drive unit. We're going to take that out. If you see any moisture on that sensor, you've got coolant inside of the drive unit. Now, the thing is, a lot of the aftermarket world have actually seen these before because they were in the 2012 Toyota RAV4 EVs and they were in the 2012 Mercedes B-Class EVs. So, there are upgrades. People have been drilling holes, weep holes into the to the case to drain coolant. We're selling block-off plates. There is rebuilding that can happen. Um, I will be honest with you. It is one of the things that I am taking a class on this year because it's pretty new to us. It's not something that we've known as an aftermarket world. It's always been replace, 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 and now we've got rebuild. Testing. We're going to test this large rear drive unit. So this is going to be on the passenger side of the car. We're going to take our meter. We've got our B plus and our B negative. We're going to be B plus to chassis, B negative to chassis. 500 volts, we want to see more than 4 mega ohms, right? Next, PTC heaters. Very common. Probably the most common isolation ticket that I get hit with. Now, way PTC heaters work is they take the high voltage power and they run across a bunch of IGBTs and resistors. Those are hooked to ceramic grids that capture the heat and allow the blower motor to push the heat into the cabin. Now, what usually happens is one of these IGBTs or one of these resistors burns out and we lose a grid. Testing is pretty simple. We're going to take our meter. We're going to do B plus to chassis, B negative to chassis at 250 volts. Now, one thing I do want to point out just real quick, take a peek at that harness back there. You got red and black tape. Sometimes if the guys at the factory liked you enough, they would tape these off so it was much easier to find positive and negative. But if you're looking for positive and negative, it will be either marked on the connector or on the component. Next big one that we saw, especially in Model X and S's pre-2021, battery coolant heater, right? This guy works just like the PTC heater, but instead of warming the cabin, it's warming the coolant. Failures would usually happen, especially in the older LG models that they made a service bulletin over, where coolant would leak past the cells, or excuse me, the seals, hit the circuit board, cause an isolation. We also see same thing when we burn out an IGBT or a resistor. Now, most of the time that we see battery coolant heater failures, it is going to be at a Tesla supercharger. And the reason for that, is because that is when the battery coolant heater is used most. And the last one we'll talk about real quick. Let's talk about the AC compressor for heat pump vehicles, right? This is one of those things that we are starting to see regularly, or at least I am. Most of the time, they don't cause isolation issues, right? They just kind of destroy themselves pretty aggressively. Now, this happens because one of two reasons. The first reason is being people, especially at like auction yards, don't check the instruction manuals when they do an evacuate and recharge. In the service manual, it very clearly tells you that you have to open up all of the refrigerant valves. So what happens is they evacuate, they notice that they've got less than what they should. Oh, it has a leak. Doesn't matter. Fill it, let it go to auction. They fill it, somehow it gets cut on for long enough that the overcharge destroys the scrolls. As you can see, there's a lot of oil in that. The other thing that's really been brought up is that they have a very long desiccant bag service. And are we seeing metal kind of getting into this compressor early? Now, hasn't happened enough where Tesla's kind of breaking apart and looking into it. I'm sure they have a little bit, but um, every once in a while, these will cause an isolation issue right before the complete failure of the scroll. So with that and my time, I think I've shoved just enough into your brain to have you guys come back for some more. So, questions, comments, concerns. For those who don't have any, I hope you've had a great evening. I hope I've taught you a bunch. If not, ask me questions. I'm happy to answer them. So, thank you all for joining. Go eat some dinner if it's that time. My guy in Brazil, go to sleep. It's time. Thank you guys. Thank you all. Louise, it's gonna be a good sleep. I promise. Yeah, sorry, Eddie. No dinner with this one. It was BYOD. The meter model is a Klein Tools ET600. Let me see if I can get a picture pulled up. ET600. Thank you, thank you, thank you. Thanks for coming. Don't forget to be on that Opus IVS website to find uh, our next class. I know that we've got some Hyundai Kia stuff coming up. We've probably got some more Audi Volkswagen. Wow, we've got people from Japan. Thanks for coming in. The good old Brandon M dropping that training link for us. Adrian, I wouldn't say I've used it daily, but I have used it a lot. I have kicked it. I have dropped it. It has been beaten, and it's been a great meter for me. Thanks, Steve, for coming in. We're all having dinner, and our viewers from Japan are going to be having breakfast. For blower motor, you said both wires checked against body, 240 volts. So, Addy, that one is going to be the PTC heater. So it's going to be near the blower motor, but it's going to be a separate component. That one is checked at 250 volts to chassis ground. Well, yeah. So positive of your meter will be into the connector of the PTC heater. And then your negative of your meter is going to go to chassis ground at 250. Thanks for coming in, Chris. Ah, Vancouver. It is. I was just there. We taught a class there. Ooh, Mike, is there another class that covers Hville? That is probably going to be my next one. Hville is just it's a little bit of a monster sometimes, especially when it's not constant. In the next webinar, can you explain how to evacuate and recharge coolant AC system? Absolutely. I think we do have a heat pump class coming up, if I'm not mistaken. Mike, you sound like you've had some issues with Hville, just like I have. The hardest part about dealing with Hville from my office is that I'm in my office and I'm not at the car. So. All right, guys, look, we're going to go ahead and get the webinar closed up. Keep your eye out. It will be on the. Oh, you're for. I feel like I recognize your name too, which is I don't know. We're gonna go ahead and close the webinar. Keep your eye out for YouTube. We should have a recording posted at some point in time in the near future. Um, And just thank you guys so much. Huge attendance tonight. Really happy to have all of you guys here. Uh, until next time, I hope you guys have a great night and a great President's Day. So, good night.